Good day, everyone. Today we are solving this question, parentheses minus x to the power of 0, parentheses to the power of root of pi. In this type of question, we're going to look into what can we simplify first, then we go into that. Straight. The first thing I can see here is I can see that x is to the power of 0, and according to index rule, any number variable to the power of 0 obviously equals to 1. So definitely x to the power of 0 equals 1. Even if it is x plus y, all in parentheses, once it is to the power of 0, surely it's going to be equal to 1. So I can see that what I have here is just 1. This is where quite a number of people do make mistake from my experience, because a lot of people will ever think minus x to the power of 0 is equals to 1. This is not correct. That is what majority of people will actually do. This is not equal to 1. Actually, minus x to the power of 0 equals to minus 1. But if we say, for instance, minus x all in parentheses to the power of 0, now this is when it is equal to 1. If look critically, this can be written as minus 1 multiplied by x raised to the power of 0. Yeah, what I have here is just the same thing as what I have here. It's just another way of writing minus x to the power of 0, because this power of 0 only affects this x. It doesn't affect the minus 1. That is why at the end of the day, minus x to the power of 0 is surely minus 1. This I know for sure a lot of people still make mistake of in solving mathematical problem, and this is equals to minus 1 times 1. So x to the power of 0 is 1, then the minus 1 by the left hand side stay there, so minus 1 times 1 then please going to be minus 1 at the end of the day. Having established that this is valid, we can now continue with the solution. So our question, the expression is now going to become minus 1 to the power of root of pi. Therefore, I'm having minus 1 in parentheses then the root of pi. Actually, what I'm saying here look like one of the Euler's identities, and that is what I'm going to apply here. And what does it say? I then leave an exponential of pi I plus 1 equals to 0. Then if I could make the exponential parts subject of formula, then I'm going to have exponential pi I equals to minus 1. Or this could be written as minus 1 equals to exponential pi I. So this establishment is very, very important. So this expression here can then be written by replacing minus 1 with exponential pi I, since it is established that minus 1 is equal to exponential pi I. So that is minus 1 in parentheses raised to the power of root of pi can now be written as, because minus 1 is going to be replaced by exponential of pi I. So instead of writing minus 1 here, I'm going to write exponential pi to the power of pi I, then that is minus 1, then raised to the power of root of pi. According to an index rule that says if I have a to the power of m in parentheses like this, then I have another power which is n, then I can multiply the power inside the parentheses and the power outside the parentheses together by saying a to the power of n can be multiplied by n. Now I have exponential of pi multiplied by I, then multiplied by root of pi. Definitely I can relate this and this together, knowing fully well that the root of pi is just the same thing as the I raised to the power of half. So this can now be written as exponential to the power of I multiplied by pi, then multiplied by another pi but raised to the power of half. Around here, if I apply an index rule that says if I have a to the power of m multiplied by another a to the power of m, I easily pick one, then add the power together. Is going to be a to the power of m plus a. the same base AA, then the same base here. There is 1 here to the power of 1 pi. So I can apply that to this part. Now I'm going to have exponential to the power of I multiplied by pi raised by the power of 1, then plus half. If I had 1 plus 1.5 here, definitely 1 plus half, that is 1.5, is going to give me 3/2. At the end of the day, I'm going to have exponential of I multiplied by pi, then raised to the power of 3/2. I can rewrite this, which is still the same thing, equals to exponential of pi to the power of 3/2, then I. There is a certain Euler equation which I'm going to need to apply here. What does it say? Whenever I have exponential raised to the power of theta I, this can be written as cos theta plus I, then sine theta. Yeah, if I look at what I have here, this equation is similar to what my expression is here, because theta is the one that stands for pi to the power of 3/2, while I still have I as it is here also in the same format. So writing this in the same way, this is my theta said earlier on. Theta equals to pi 3 raised to the power of 3/2. So at the end of the day, this is going to be equal to cos of pi to the power of 3/2 plus I, then sine pi raised to the power of 3/2. So if I use calculator to solve this further, what am I going to have? Cos pi raised to the power of 3/2. That's going to give me 0.995, then plus, then sine of pi raised to the power of 3/2. What is it going to give me? That's going to give me 0.097 I. That is my final answer. Therefore, my question from the beginning, which is minus x to the power of 0, all in parentheses raised to the power of root pi, equals to this minus x to the power of 0 all to the power of root pi, is just equal to 0.995. That is a complex number, 0.097 I. If you have ever learned anything, no matter how small it is, right from the beginning, kindly subscribe, like, share. Is going to go a long way. That is this.